Mitch. Mitch, unmute your microphone.
Hello.
Hi, how are you today?
Good, how are you?
Good. Did you send me stuff, or are you going to be able to verbalize it?
It's supposed to be sending now, but I will verbalize some of it.
Okay.
So it's just a simple problem, but it's what is the limit of tangent x over 2x?
Let me guess, 0.
Yeah.
Well, by direct substitution, we get 0 over 0, right?
Yeah.
So we got to do something to one of them. Can't do much with 2x, but what's tangent x equal to?
Isn't it's sine over cosine?
So now the problem becomes this, right?
Yeah.
Well, we know what's this limit? As x goes to, what is it?
1.
Okay, what is this limit?
1/2. No, 2. It's
2, because we would have to multiply the top by 2. And now we know that that limit would be, hold on a minute, confusing myself here, hold on. The limit of sine of x over 2x, well, you could multiply top, oh, I just realized why this is not that simple. It is 1/2. In other words, we know that limit there, right?
Yeah.
That's 1. Well, the 2 doesn't affect anything, so that limit is 1/2. So we know that limit is 1/2, and we can separate this thing into the sine x over 2x times 1 over cosine of x. That's the same as what we started with, correct?
Yeah.
What's the limit of 1 over cosine x as x goes to 0?
Isn't that 1?
Yeah, because this one goes to 1. In other words, by just direct substitution, you get 1 over 1 times 1 over 1/2, so this limit is 1/2.
Alright.
And it actually illustrates that the limit of tan of x over x is also 1. It's like sine of x over x. The limit of tan x over x must be 1. Because it's sine x over x times cosine x. And since that part is 1, all right, let me open up your document here.
It's a sequence and series problem.
Okay.
And I totally forgot how to do them. So
Number 7.
7 and 8, yeah.
Okay. Find the sum of the terms. Hold on. Well, let's write a couple of these terms. What kind of sequence is this? Is it arithmetic or geometric?
Arithmetic.
Correct. 3 terms tell us that. There's a formula that you have to remember. The sum of an arithmetic series. It's equal to first term plus the nth term. What is it?
Divide by 2. Divide by 2.
I think you have to divide by n. Hold on a minute. Let me
Wait.
look it up. You have your book open. Can you look it up real quick?
I have my worksheet, so I'll try to find it. But I thought it was like a sub n over 1 minus r.
That's for a geometric series.
Oh.
For an arithmetic series, I'm pretty sure it's this. A sub 1 plus A sub n over 2. I think it's that.
Oh, it's not divided by 1, it's just n.
That's what I've got there.
Yeah, it's n. It's
Not
not 1
divided
over
by
n.
2?
No, it's a sub 1 plus a sub n divided by 2, but it's not 1 over n. It's just n.
Oh, it's just n. Okay. All right. And we can figure out all of those things here. We can see what a sub 1 and a sub n is, right? They've listed both of those.
Yeah.
So the only thing we need to figure out is how many terms there are. Well, to figure that out, let's go back and figure out what is the nth term definition for an arithmetic series.
The a sub 1 plus n minus 1 times d.
Uh-huh. Well, again, we know what the nth term is, we know what the first term is, and we know what d is. So this is going to tell us n. So, a sub n, fill in everything for me. What's a sub n?
Negative 75.5.
And that's equal to?
2.5. And then n minus 1. And then negative 3.
So now we have to solve that algebra problem for n. Well, how do I do that?
Would you transfer the 2.5 to the other side?
Okay, that's a good starter. Minus 78 equals, now what?
Negative 3n plus 3.
Let's move that 3 over to the other side. What's n equal to?
27.
All right.
Yeah.
So now that we know what n is, we know everything in that formula. We know n, we know a sub 1, we know a sub n.
All right.
Okay? So all of these series questions, you want to know 2 things about arithmetic series. You want to know the general formula for the nth term, which you knew, and you want to know the general formula for the sum.
Alright.
You know those 2 formulas, you're going to do fine. There won't be anything you can't do with these. So, give me the same 2 formulas for a geometric sequence.
Wouldn't it be, for that one, it would be a sub n, would it be a sub 1 times r to n? Or is it n minus 1?
Always n minus 1.
Okay.
Okay? And if you don't remember that, just take a common geometric series like that. I'll write 4 terms out. See if you can figure out what the 4th term is. If this is not the correct formula, it won't be 16. If it's 16, we got the correct formula. So what is a sub 4?
It would be 2 times 2 to the third.
16. We got it right. In other words, if you were to make a mistake and leave off that and think that that was the formula, it would fail this test, right?
Yeah.
It would have been 2 to the 4th. And that's 16 times 2, 32 would have been the 4th term. But we can look at the thing and we can see that 16 is the 4th term. So we must have the formula wrong, and it's got to be an n minus 1. Now what's the summation formula for a geometric series? We'll call this arithmetic, we'll call this geometric.
Is it a sub n to equals n parentheses?
I'm going to have to look it up if you don't know it. I know what it is for an infinite geometric series. It's a over 1 minus r.
Yeah, I have it right here. I was trying to do it by memory, but that was a failure. It would be a sub 1 parentheses r minus n, r 1 minus r to the n. So it's 1 minus r. There, to the n. 1 minus r to the n over 1 minus r.
Now notice why an infinite series moves into that. At least I used to know. In other words, an infinite series is where n goes to infinity, right?
Yeah.
Well, how does this thing turn into a over 1 minus r when n goes to infinity? I don't think that's right for the summation. Let me get my book.
Yeah, but a sub 1 is not in the on the parentheses. Like it's all 1. Like the a 1 minus r to n over 1 minus r. It's times a sub 1.
Okay, I'm not sure that helped me. Hold on. 96. So there's the sum of a finite arithmetic, sum of a finite geometric. The n goes only there. And that's probably what you were trying to tell me. I just wasn't listening. Now, I still wonder why that turns into a over 1 minus r. In other words, as no, I still don't know. I used to know this. In other words, this is a limit problem. Okay? Let's take the limit of that summation as n goes to infinity. Because that's what an infinite series is it's assuming that it's an infinite series. N goes to infinity. So how is it that this term goes to 1? I used to know this, and I cannot figure it out right now. But maybe it's not important. You may not have to know Do you have to know the summation? In other words, from this problem that we're looking at over here, I don't think that requires you to know an infinite series, does it?
No.
No, that's a finite series, so you can use this formula that we have over here. Hold on. So let's use it. Maybe in using it, we'll discover why an infinite series is different. So plug everything in. What's a sub 1?
For the number
8. Yeah.
A sub 1 is 2.
Okay, times 1 minus r is 3 to the n power, which we don't know yet, but we're going to have to solve for that, just like we did on the other one, all over 1 minus 3. Still don't get why, as n goes to infinity, that whole thing inside the parentheses disappears. All right, a sub n, what's the explicit definition of the nth term of a geometric series?
A sub 1 times r to n minus 1.
So we need to solve for n. So the nth term is 366. So that's equal to 2 times 3 to the n minus 1, right?
39,366.
Ah. I mistook my commas. That's funny. I'm not sure how you can tell. I guess you can tell because it's not 3 times bigger, huh?
Yeah.
But it's dangerous to use commas in numbers when you're talking geometric sequences.
Yeah.
Because it's hard to distinguish between the comma separating the numbers and the comma separating the thousands position. Okay, how do we solve that for n?
You could divide both sides by 2.
Okay, that's a good start. Hold on. What happened to it? So we got 39,366 divided by 2 equals 3 to the n minus 1. Now what?
And then would you just take the log of both sides?
Yeah, when your variable is in the exponent, the solution always requires logarithms. So what kind of log am I going to take of both sides?
Would you take the log of 39,366?
No, I mean, are you going to take natural log, common log, log base 3, what?
Log base 3.
I don't think so. I mean, I know that's what they've kind of taught you to do, but that's going to give us a problem later in the problem in that we're going to have to use the change of base formula, and we're going to have to know what it is. If you don't want to have to know the change of base formula, always take the natural log of both sides. Okay? Now, we've got the natural log of 19,683. That's what that number is, I think.
Yeah, that is.
And that's equal. Now, how am I going to write that? In other words, my goal is to solve for n.
Isn't it just 3 times?
No, the rules of logarithms allow you to take the exponent and put it down on the algebra line, like this.
Yeah.
In other words, that's the same. Those two are the same.
Okay, I just had it flipped.
And now I can divide both sides by natural log of 3. That gets rid of that. And I can add 1 to both sides, and I've got n. So my n is equal to that, whatever that number is.
Okay.
And I guess I should add that it better be a whole number, right?
Yeah.
Can't be fractional. There's no way the number of terms in that geometric sequence could be 14 and a half or 4,000 and a half. It's got to be a whole number. If you do not get a whole number, we did something wrong. Do you have your calculator handy?
Yeah.
Get that number at least.
The log of, or natural log of 19,683 divided by 3?
No, divided by the natural log of 3.
Oh yeah, the natural log.
Same thing, either. What'd you get?
I'm still doing it. My calculator's not the best. It's very slow at this point.
Okay.
9.
Okay. So a whole number.
Yeah.
So n is 10.
Yeah.
And that makes sense. Actually, it is a little surprising that in a mere 10 terms, you can go from 2 all the way up to 39,366 just by multiplying each term by 3. It's kind of amazing that it grows that fast.
Yeah.
However, finding the sum, we still have to go back and using this sum formula. So now we know n is 10 here. Now we need that number. And that would be the sum. And notice that's going to be a positive number. The numerator is going to be negative, the denominator is going to be negative, and the sum will be 1 minus 3 to the 10th, the negative of that. Oh, hold it. Yeah, is it 3 to the 10th or 3 to the 9th? It's to the n, and we figured out n was 10. So, yeah, it's to the 10th.
Yeah, so it is 59,048.
And that makes sense also. If the final number is 39,000, you would expect the total to be not double that because it's a geometric sequence.
Yeah.
Bigger than that. It needs to be bigger. The total sum needs to be bigger than the last term, but in a geometric sequence, it's never going to be, well, I suppose it could be smaller if the r was 1.1 or something.
Or a negative number.
True. True.
Because it could just keep flipping back and forth.
Right. Right. Yeah, that would actually be harder to figure out, huh? If it was an alternating series and it went positive, negative, you wouldn't know whether to expect a positive number or a negative number as your sum. But both of these problems required, the only thing you needed to know was both formulas for the arithmetic and the geometric.
Okay.
You need both formulas to do either problem, because you have to figure out what n is in order to figure out the sum. And you can't figure out n without the explicit general formula for the nth term.
All right.
Okay. What else do we have?
That's pretty much it, because like we've been going over a lot of stuff in class, and I've been getting most of the stuff. I'm just not getting it on the quizzes or the tests.
Really? Okay.
Yeah, like it takes me like 3 or 4 like relearnings of things to get it.
Well, that's not that unusual. That's not unusual at all, but it takes me that also. The question is to get to the third or fourth. In other words, okay, so this is like the second relearning of arithmetic sequences. I bet you the next time you go to do it, a year from now or 2 years from now, you'll know it a little bit better, and then the next time after that, you'll know it almost perfectly.
Yeah, because on that quiz we reviewed, I got a 94,
Okay.
and I had like a 60 on it before, so just going over it with you just insanely helped.
Good.
I think this is all I need at this point.
Okay. So your final, this is our last session then, right? Before you...
No, I've one
Oh, that's
Monday.
right. You made one for Monday, I think, right?
Yeah.
Let's just double check that before I let you go. Yeah, it's 6 o'clock for an hour.
Yeah.
Okay. Sounds good. I'll talk to you Monday.
All right.
All right, Mitch. Have a good one.
All right.